Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Henderson-Hasselbalch equation relates pH, pKa, and the ratio of deprotonated to protonated species. When pH pKa, the deprotonated, conjugate base, form predominates. When pH pKa, the protonated, acid, form predominates. Moving on to the next step. Analyze acetic acid, CH3CoO, pK is equal to 4.8 at pH 7.0. Using Henderson-Hasselbalch, pH is equal to pK plus log A Ha. 7.0 is equal to 4.8 plus log CH3CoO2 CH3CoO2H. Log CH3CoO2 CH3CoO2H is equal to 2.2. CH3CoO2 CH3CoO2H is equal to 10 to 158. Since pH 7.0, pKa 4.8, the deprotonated form CH3CoO2 overwhelmingly predominates. The major species is the acetate ion CH3CoO2. Moving on to the next step. Analyze ethanol CH3CH2O. pK is equal to 16.0 at pH 7.0. Using Henderson-Hasselbalch. 7.0 is equal to 16.0 plus log CH3CH2O CH3CH2O. Log CH3CH2O CH3CH2O is equal to minus 9.0. CH3CH2O CH3CH2O is equal to 10.9. Since pH 7.0, pKa 16.0, the protonated form CH3CH2O overwhelmingly predominates. The major species is ethanol itself, CH3CH2O. And for the final step, identify the major species. Major species CH3CoO2 acetate and CH3CH2O ethanol. Why other options fail? A. CH3CoO2H and CH3CoO2O incorrect. Acetic acid would be mostly deprotonated at pH 7 and CH3CoO2O is not a meaningful species here. B. CH3CH2O and CH3CH2O incorrect. Ethoxide CH3CH2O would not be the major form at pH 7 since pK of ethanol is 16. C. CH3CoO2H and CH3CH2O incorrect on both counts. Acetic acid is mostly deprotonated at pH 7 and ethoxide is not significant at pH 7. D. CH3CoO2 and CH3CH2O correct. Acetate predominates, pH pK of acetic acid, and ethanol predominates, pH pK of ethanol. Therefore, the correct answer is D. Therefore, the correct answer is option D.